with the old and in with the new. The construction of new buildings in Australia is literally a growth industry, but is it a green one? The trouble with building from scratch, particularly in the inner city, is you often have to knock something else down first. Over 40% of all the waste produced in Australia comes from construction and demolition. Much of this is sent to landfill, about 6 million tonnes of waste per year. It's a problem that we just can't keep burying in the ground. So while you may think you're already doing your bit to recycle bottles, cans and papers, we may soon have to start thinking on a much bigger scale. I'm talking about recycling a whole building.
We've got so much commercial building stock that needs reworking in Melbourne and across all of the Australian cities. Tired, old building stock that was developed before environmental concerns became an issue.
What potential do you see in a building like this one?
This building's got bricks, it's got timber, it's got steel, there's bits of glass left, and there's concrete. All of those materials can, given the right conditions, be recycled or reused.
To calculate the environmental benefits of saving these materials, scientists turn to life cycle analysis.
We quantify the materials that are required to produce a building, the tonnes of steel, the cubic metres of concrete, and we use what we call embodied energy coefficients. Embodied energy is the energy that goes into producing something before you even get to the point of using it. If we look at concrete, we need about 5 gigajoules of energy to produce 1 cubic metre of concrete. A similar example is steel. We need about 85 gigajoules of energy to produce a tonne of steel. And that's about the energy that you would need to operate an average house for a whole year.
With all that embodied energy trapped in our buildings, we need to know exactly what and how much can be used again. Here, at this plant in Victoria, engineers have found a way to crush down and recycle old concrete, processing over 1 million tonnes per year.
We've commissioned a life cycle analysis that RMIT did, and they compared this process of concrete recycling with the traditional process of taking concrete to landfill and then building roads from material that was quarried. And this process has got about 65% less carbon emissions.
A lot of concrete has steel reinforcing in there.
Yes.
Can you recover that? Because that's got a lot of embodied energy in it.
Yeah, sure. So a large part of that carbon benefit is the steel that's recovered that can then be recycled. And then there's other materials that we need to get out, things like timber and plastic and those types of things that need to be removed before it can be used as an end product.
Concrete is the second most commonly used material on Earth after water. The sheer amount of it we produce makes it the heavyweight champion when it comes to embodied energy, emissions, and as a potential contributor to landfill. During the manufacture of cement, the active ingredient in concrete, limestone is heated until it breaks down into calcium oxide. But it also releases a byproduct, carbon dioxide, at a global rate of 2 billion tonnes a year. But there is an alternative that replaces limestone with a more environmentally friendly reactor.
Instead of having a calcium-based system, as is the case with normal cement, you have to switch the chemistry to an aluminium-silicon system.
This greener process uses slag and fly ash as the reactive agents instead of calcium. Both are byproducts from other industrial processes. The result is a geopolymeric concrete with a much lower carbon footprint. This is just one of the technologies being applied to our new homes and offices. But green doesn't have to mean new. Cutting-edge technologies are also being used to retrofit some of Melbourne's historical buildings. Like these derelict 120-year-old railway sheds right in the heart of Melbourne's Docklands. 18 months ago, work began to transform the north end of the shed into Victoria's only 5-star rated heritage-listed building.
We have 3 types of heating and cooling systems in the building. We've got the underfloor heating and cooling. We've got chilled beams above our heads in the smaller spaces of the building, and we've got hydronic heating. So we've got a hybrid of heating and cooling systems that match the spaces in the building.
Chilled beams are a less energy-hungry alternative to air conditioning. Instead of cooling air by refrigeration or evaporation, and then pumping it around with a fan, they use water to chill the metal beams, which in turn cool the air and the people around them. Hydronic heaters also make use of water to circulate warmth throughout the office space more efficiently and comfortably than traditional forced air heating.
We have a huge roof. It's a whole city block long. That roof is actually a water catchment, and we've got an 80,000 litre tank to capture that water. It was important because this is one of the harder buildings to turn into a green building. And so in a sense, if you can do it in the old goods shed, you can do it anywhere.
With buildings like these representing the gold standard for what can be achieved with existing materials, we now know that we can take what we've got, make it better, and leave a legacy of green buildings that will stand the test of time.